Let's do this one. About yield, right? Because you will have a limiting reactant problem in your exam, you will have a yield problem. Very similar to the practical exam, okay? And it's beautiful. Your teacher is very happy to see these things happening. Some student at the end of the last lecture said, you know, I have a lab and I cannot make it to the review session. Is there any way you can ask, you know? So there you go. There was a student who just popped up and said, I will do it. So somebody is videotaping there from your own, he's one of your classmates. I mean, yes, classmates. He's doing the videotaping right now. And everybody who will come will be able to see it. He's going to spend a few hours to put it on YouTube, to work on it. Okay? I want you to think about this. Try to come to a mental state that you can offer of your time to other people with no credit, just for the sake of doing it, and see how your lives will change. See how your grades are going to go up instead of worrying about them. See how many things, beautiful things will happen to you by just devoting every day some time for other people without asking for something back. Your lives are going to be completely changed. Trust me. Try it. Because the culture we're in is pushing us to always think about me, me, me. And that makes us at the end really sick. And we cannot enjoy anything. Even if we have a good grade, we cannot enjoy them because we have no peace of mind. Is that true? So some students are getting it. Some students do it. And usually they are the highest scored people in different classes. And people that have changed it, right? They were not born like this. They made the try, they changed it, and now they're really doing really good. I have so many stories. Go to thelifecurve.com, read the stories of students. I didn't write them, students wrote them. And they made the effort. By making that effort, there is a lot of big changes happening to their lives. They were not born like that, but they made the effort to change things, okay? So if they can do it, you can do it, I can do it. Isn't that true? It's true. Okay, so this problem is about yield, right? There's three types of yield. The actual yield, or sometimes called experimental yield, the real yield, what you will get when you do the reaction out there in real life. Then there is a theoretical yield, which is based on the chemical equation. You put the amounts that you're talking about that you will be using out there, but you're putting it according to the equation. So the actual yield is, we are not looking at no equation. The theoretical yield, you're finding by using the equation. The actual yield, you're not using an equation. You do the experiment, you get so many grams, or moles, whatever. The theoretical one is you're using the equation by this, using the same amounts that you would use out there, you're using the equation. That's the theoretical yield, right? And the ratio of real to theoretical, which is always a fraction, times 100 will give you the percent yield, okay? So, by the words of the problem, then you know immediately that what you have. You're looking for the percent yield. So we want percent yield. And that will be equal to actual or experimental or real, whatever you want to call it, divided by theoretical, times 100. So the only thing you have to find these two, right? If you find these two, you're done. Okay, so according to the words of the problem, it's telling you that, what do you know from the problem then? Do you know actual yield? Yes. It's 500 grams of C. So theoretical yield then, you have one product, you don't have to worry about it. Just one product, right? You refer to it. Because if there are more, these two things here, they will have to refer to the same component. You cannot say it's so many grams of C and so many grams of D or E. You have to refer to the same component. Not only that, but it has to refer to the same units. Okay, so here, I'm going to find out a number in grams of C. This is coming from experiment. This comes from equation from the cartoon. Okay, this comes from equation, this comes from experiment. So, if that's true, then I'm looking at the equation, right? I have the molar masses, right? Molar mass of A is equal to 20 grams per mole, and I have the molar mass of C, which is 72 grams per mole. Okay, so if you want to, so here is the equation. When we do problems, we said, what do? We always write down the equation. So 2A plus B, it gives you 3C. 2A plus B gives you 3C. Okay, so now we want to find the theoretical yield. And then we're done. We know this number there, we're done. And from the equation, here is the equation. So you start with what? 100 grams of A, right? 100 grams of A. That's the only thing you know, actually. So this is not a theoretical, a limiting one, is it? Does it take anything about B? No. No? It doesn't talk about B, does it? Okay, so it's not a problem of limiting, right? We don't have a problem about deciding which is the limiting reactant there, because you just have the A. It is assumed, therefore, right? It doesn't take anything about B, right? It's assumed that it's an excess, right? Okay. Everybody got that? It does not talk about B, that means it's assumed always as a rule. We said it's in excess, so it's assumed that all of these A react, yes? But we're not going to get that number there, we're not going to get what the equation is telling us, because when we use 100 grams of A, it's not pure 100%, maybe it's 80% pure. And for the other reasons we said in the lecture, you will not get as much as you would expect, it will be less, right? But assuming that all the conditions we said before are ideal, then from 100 grams, according to this equation, by knowing the molar mass of C, we should get how many grams? And that's what we want to find out, yes? Okay, so we start with what we have. What do we have? We have 100 grams of A, right? So start with it. So here is a train that we're going to construct now here. We have 100 grams of A, right? And we want to go into what? Grams of C. So what are we going to do? You remember? Grams of A will go to moles, and then from moles of A to moles of C through the equation, and then from moles for C to grams of C through the molar mass of C. That's it. You remember this kind of thing? That general scheme? We've done some problems in section, huh? So I have grams of A, and I want to go on grams of C. How I'm going to go from grams to grams through the equation? I have to go first to moles. So grams of A will become moles using the molar mass, and then from moles through the ratio 2 to 3, I'm going to get how many moles of C I get, and then knowing how many moles of C using the molar mass of C, I will have how many grams of C I get. Everybody got it? Okay. So in this case, then I'm going to get this out of there because I want grams of C, no grams of A. So in order to get it out of there, I have grams of A there to get it out. And that's the molar mass we're using, right? So 1 mole of A is how many grams? 20 grams of A. Good. Now, I don't want moles of A. So if I don't want moles of A, it has to go out. And I will go to moles of C because I want grams of C. So what's the ratio between the two? I have 2 moles of A for every 3 moles of C. Okay, so I have moles of C. Well, if I want grams of C, I want them there. And if I don't want moles of C, it has to go there. That's the molar mass, right? So 1 mole of C, how many grams? 72. All right, you see how I thought about it again? All the units are gone, and the only thing that stays is this. Okay, so if you put them all together now, 100 times 1 times 3 times 72 divided by 20 times 2 times 1, all these numbers together, that's grams of C. And you will find out that it's 540 grams of C. Now, here is, you have to be smart. Always check. if this is theoretical and the other is actual, you always know that theoretical should be larger. So if it's smaller, oh, wait a minute, I'm doing something wrong here. You see? You always check that way. All right, so we have the 540. So this is 540 then. And so these two numbers divided will give you, times 100 will give you the percent yield. Right? It's going to be 500 grams of C divided by 540 grams of C. They have to be same thing. Here you say, okay, well, C. Well, other reactions might have more products than one. Don't go and put put different things. They have to be the same component and the same units. Grams, moles, number of atoms, whatever. Tons, ANU, it doesn't matter. As long as they're the same units, it doesn't matter. Right? Times 100 will give you the percent yield, which comes up to be here, 92.6%. Okay? Now you should really do any kind of yield problem. Don't you agree with that? Okay. Should we do a balanced equation or no? What should we do? Chemical reactor? I thought it was this. Well, we did already. You want to do one? Okay, let's make up one. Let's make up one. Let's say A plus 2B, 3C gives you 5E. Okay? So let's say that we have, we can put grams here and give you the molar masses of here and make it harder. But let's not make it so hard to spend too much time, right? Because if I want to find the limiting reactant, right, I cannot work with grams. Why? Because I have to look into the equation to find out the limiting reactant. Yes or no? You have to. If you look at the equation, these numbers 1, 2, 3, whatever they are, the coefficients of the chemical equation, they refer to moles. So if I give you so many grams of this, and so many grams of that, and so many grams of that, how many grams of that, then you will have to convert the grams into moles. Because to find out how many grams of this you get, you will have to go to the equation to use the ratio of the numbers. And the ratio of the numbers refer to moles, not grams. So I cannot use these numbers to do that. I have to convert them first to moles. So instead, so if I give you grams, then you have to convert it to moles. Yes? So let's not do it that way to spend time. Let's give it in moles now, right? So let's say I give you, 2 moles of A. Let's see if I give you 5 moles of this. And what do you want from here? Maybe 3 moles? Whatever, it doesn't matter. By accident. Okay? 2 moles, 5 moles, 3 moles. Okay? If it was grams, I have to know the molar mass and get into moles. Now from this, and the equation, how many grams of this, I have to know the molar mass of it. Let's say that the molar mass of it is, what do you want? 771. Okay? So if I find how many moles of E, by the molar mass I can find how many grams. Yes? So the question is then, how many moles of this I get? From this, and that, how many moles of this? If this is the equation, what are we going to do? It's not like the other one that was only 2. That was easy, right? 2 numbers, you can just watch them and you can really decide. How are you going to do this now? How about if you had 5 of them or 6 reactants? How are you going to do it? Well, like here, then you have to do it the way we said. By just, nobody just looking because you'll go crazy by just looking. You will have to do it the way we said, the slow way. That means you calculate how many moles of E you get from each one of them, and then you choose the smallest number, okay? So let's do the first one, okay? You start with what? 2 moles of A, 2 moles of A, and then we get the way and we can do it faster. Just do it one time only, okay? 2 moles of A, how many moles of E? Let's see, 2 moles of A, and the ratio is what? I have 1 mole of A here, and I have 1 moles of D there. So how many, what's the ratio? A to E? 1 to 5, okay? Moles of A goes away, and we have 10. Or we can say from 1 you get 5, from 2 you will get 10, okay? That, you didn't have to do this. 10 moles of E, okay? And then for the B, it will be what? 2. So you don't have to write all these things down. It's not to show your work, right? So what are you going to do? You will say 5 times moles of E, which is what? 5, right? Divide by 2. So it will be what? 25 divided by 2. Right? Correct? Because you see from here it's really hard to say. 2, they make 5. 5 will make how much? That's not easy, right? So it's going to be 5 times 5 divided by 2 is going to be 25 divided by 2 is 12.5 moles of E. Right? And the other one is going to be what? 2 gives you 3 gives you 5. Oh, 3. Oh, okay, that's 5. Immediately, we don't have to do anything, right? There is to see it, right? 3 gives you 5, happen to have 3, so that should give you 5. If that was a limited reaction, right? If that was the react all of it, right? So now we have this, and that. Which is the smallest? This. Therefore, this is going to be how many moles of E you will get. And the limiting reactant would be C, would be the limiting reactant. You want to do well? Try to sing, dance, even though in the beginning your mind is going to tell you, you must be crazy. You are not like that, you are crazy. You know? I have to meet deadlines too. Don't be in a hurry, we are the best thing. How many minutes do we have? You want to know what? Huh? 8 minutes? Why are you in a hurry? Why are you in a hurry? Why? You don't want to hear the best? I have a story for you. I have a story for you. You know, he wants to hear it. He wants really bad to hear it. I have all sorts of deadlines to meet. And always the thought says, oh, no, I got to do this, I got to do that. You know? By this Friday, it's too bad. I didn't sign any papers. By this Friday, Friday passed away. I didn't do by Friday, this Friday. All those people are going to be so nice. You can send to us the manuscript by Thursday. Next Thursday, we'll do it by Friday. And I'm thinking, sure, I'll try my best, I said. But hey, listen, even if I don't do it for the second week, who cares? Let me go for the 3rd week. Now, listen to this. You know, I say I'm going to do my best. If I can do it in 2 weeks, instead of 1 or 3, it would be great instead of 3, right? So, I said, how am I going to do it? If I stress myself, first of all, I will get sick, physically sick. Second, I will make mistakes, all kinds of crazy things are going to happen, I will delay it more. So, hey, we need to get a booster shot now. What do you mean by that? Put some music. So I'm in my place. I put the music and I put it really loud in the room because we got to get some medicine, right? Some medicine. So we can make it. Actually, I made it. 16 UPS. I was at UPS at 6 o'clock for manuscript left. 6 o'clock today. I made it. You know, I said, I'll try, and I made it. Instead, I said, maybe the other week, I made it the one week you do it. But you see, I got my medicine. I put my music. I took my tambourine and I started singing and dancing for about 10-15 minutes in the morning. And you know what happened? You wouldn't believe it. There is a lady in my house. With everyone makes his journey. This is not about criticizing anyone. We're talking about reality. If you are not careful now that you're young, you will come to a point when you get old and you will see everything dark, everything night, everything negative, everything bad, sour, bitter. Nothing will be sweet. Nothing. You will not have one word in your mouth that will be positive and beautiful. You'll always complain. It might happen to us if we do not take care of our mind now. So, the old lady, I can hear steps. There is leaves from the trees, like, no, somebody's coming. But that doesn't matter. I'm in my own world. And look, at that moment that you're in that mental state, that you play your music and you're really happy, decisions are made like a lightning, like this, look. A lot of things that you need to decide, you decide intuitively what you will do and what you will say. And what you have to do so you will not forget, they come up like this, look. Intuitively from inside you. And in fact, some things that they've never thought, to avoid traps and troubles and so on and so forth, they come to your mind and the solutions come to your mind like this, look. You don't believe it? How many people have this experience? Let me see your hands. When you are in that mental state, that you're so blissful state, all these answers to questions that they might bother you for weeks, you can get really the answers, perfect answers, and even for things that you've never thought, at that moment you solve the problems. How many people have this experience? Let me see your hands. Some people do, okay? And they believe it. You believe it even if you didn't have this experience. So, I hear the noise, and who's coming at the door? Who do you think? Huh? I see. What's wrong with you? That was my mother-in-law. So she looks me at this like this, she sees me with the blasting the music and dancing, and says, she seriously said this, what's wrong with you? Do you see that everything is relative in this world? Everything is relative. Everything is relative. Do you understand what I'm saying? Everything is relative. If you are such a negative attitude all the time, when you see somebody in a blissful state, you will believe this person is mentally ill, is crazy. Yeah. Let's try now that we are young, now that you're young, and our faculties work to control the mind, to keep the positive thoughts and watch the negative thoughts. Don't even think negative, just concentrate, focus on positive thinking. Okay? Goodbye.